Okay, in this application problem, we have a ball is thrown straight up from 3 meters above the ground with a velocity of 14 meters per second. It is modeled with the equation h of t equals negative 5t squared plus 14t plus 3. So what that would look like if Danny the dino right here was a ball and he was 3 meters above the ground and I throw him straight up with initial velocity of 14, well crap, there's a wall there, pretend like it's not there, 14, what is the height? So obviously the initial height is going to be 3 meters. But then the height is going to change because I throw it up with a velocity of 14 meters per second. But if I'm throwing it straight up with a velocity of 14 meters per second, why does it come back down? What force is acting upon Danny to make him come back down? So we have the equation negative 5t squared plus 14t plus 3. Well, it outlines in the problem for us that 14 is the initial velocity. So the initial velocity the ball is thrown at is 14 meters per second. It also tells us that the ball starts 3 meters above the ground. So 3 meters is the starting position. So, what does this negative 5 mean? What does negative 5 mean? Well, if we think about Danny the dino, he went straight up, but some force was acting on him to come back down. Ooh, gravity. That dang gravity. Gravity was acting upon Danny, and so negative 5 would be the force of gravity. Of course, I want you to keep in mind that negative 5 is not actually gravity. Gravity is approximately negative 10 meters per second squared. But because we're putting this in a quadratic equation, some calculus stuff happens, and it's actually negative 5 that we plug in here. If we were talking about feet per second squared, we would plug in negative 16 because the force of gravity is negative 32 feet per second squared. So the number that you put in your quadratic is always going to be half of what the actual force of gravity is. Okay, so we've identified what negative 5, 14, and 3 mean. So what is the maximum height of the ball? Well, if we drew this out, Danny the dino started at 3 meters. And, well, we could graph this out. Let's use our calculator to start. So we've got negative 5x squared plus 14x plus 3. And we've got some points. So 1 second later, Danny the dino was up at 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 2 seconds he was at here. And then I'll go 3 seconds, 0. So there is our model. Well, maximum height. Maximum height is going to be whatever this point is. How do I find my maximum? Oh yeah, I can use the equation x equals negative b over 2a. Well, b is 14, so the opposite of 14 would be negative 14 over 2 times negative 5 is negative 10. I'm going to simplify my fraction because I'm really, really cool, and I'm going to get 7/2. So my maximum occurs at 7/2. Well, 7/2 is 3.5 minutes, seconds. Hit pause. What broke? Guys, there's actually a pause button on this video, so that's kind of cool. I'm hoping that you already noticed what I did wrong. Remember when I said I can simplify fractions because I'm really, really cool? I didn't simplify my fraction correctly. So this should be 7/5 because I'm really, really cool and I can simplify my fractions. So 7/5 would be our time. And then to find the actual height, because we're looking for height, we would plug that in to our equation. So we would have -5 times 7/5 squared plus 14 times 7/5 plus 3. And hopefully this makes more sense now. How did I know that I made a mistake? Well, 7 divided by 2 was 3.5, and I already drawn on my graph that at 3 it was a 0, so there was no way that could be a maximum. So those are some good skills as you're working through problems. If you make a mistake, to go back and just think about what did I do and where could I have gone wrong. So right here I have that my maximum height is 12.8 meters. Does that make sense as I look through here? So 7/5 is a little bit more than 1, right? And so it would make sense. That does make sense. And we could also go to our graph. So I'm going to change this so we know it hits 0. So I'll go up to 5, go 0 to 15. And there's our graph. And you could calculate the maximum on here. And I'm just really just double checking to make sure that this makes sense. And look at that, 12.8 is our maximum. So it makes sense. Okay, so when will the ball hit the ground? Well, when the ball hit the ground, my height has to be 0, right? So if my height is 0, I could take my whole equation and set it equal to 0 and solve. I could look at my graph and we already know that it hits 0 here. But let's solve it just for fun. So you could factor by grouping, you could complete the square, you could do the quadratic formula. Really, you can do whatever method you want. I think that this is probably a pretty easily factorable one. So I'm going to try factoring it. I could be wrong. I make mistakes here and there. I'm going to try factoring because this is a prime number and that's a prime number. So this has to be a -5 and this has to be a t, because -5t and times t is the only way I'm going to get a -5t squared. And then I want +3 at the end. So that means one of them has to be 3 and one has to be 1. This is going to add up to 1t. This is going to add up to -15t. Multiply to, not add. So if I want a +14, I'm going to make this negative and this negative. I can check and see if I'm right. So if I check it, that's my original. I can plug in -5x minus 1 times x minus 3. And since it maps right over the other one, I know that I factored correctly. So set each of these equal to 0 and solve. And so I'm going to add 1. So I get -5t equals 1. T equals -1/5. And then here, t minus 3 equals 0. T equals 3. This does not work. We can't have negative time. This is what we call an extraneous answer. And so t equals 3. 3 seconds after we throw it up.